Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR NET, GATE, SET exam, PhD exam, NTA exam, TIFR, Jest, IIT-Jam exam and other exams related to physical science. And also guys, I would like to request the people who haven't subscribed my channel yet, please subscribe my channel. And this is the lecture number 7 of quantum mechanics PYQ. So I'm going to start now. So I'll start with question number first. Okay. The question number first is, if psi NLM if psi NLM denotes the actually this question was left in last lecture because that time, because of technical glitch, my class was ended automatically. So and that's why I was not able to solve this question. So I'm going to start with this question now. Okay, so if psi NLM denotes the eigenfunction eigenfunction of the Hamiltonian of the Hamiltonian of the Hamiltonian with a potential with a potential V equal to VR, V equal to V, which is function of R, then the expectation value of expectation value of the operator Lx square plus Ly square in the state psi equal to 1 upon 5 3 psi 211 3 psi 211 plus psi 210 minus root 15 psi 21 minus 1. Okay, this is the one is, and options are given. Option number A is 39 h cut square upon 25. 39 h cut square upon 25. Option B is 13 h cut square 13 h cut square upon 25. Option C is 2 h cut square, and option D is 26 h cut square upon 25. 26 h cut square upon 25. Okay. Well, this is the question. So psi NLM, where n is the principal quantum number, n is the angular quantum number, and n is the magnetic quantum number. Okay. Psi NLM denotes the eigenfunction of Hamiltonian with potential. The potential is function of VR. Then the expectation value of the operator Lx square plus Ly square in this state psi, which is given 1 upon 5 into 3 psi 211 plus psi 210 minus root 15 psi 21 minus 1 is. Okay. So this is the question. So I'm going to solve it, which was left in last lecture because my class was ended automatically. So I'm solving it now. Okay. So we have been given psi equal to 1 upon 5 3 psi 211 okay, plus psi 210 minus root 15 psi 21 minus 1. Okay, this is given, and so here we know this is a formula, guys. You need to note down L square, that is angular momentum operator, angular momentum operator, okay, is equal to Lx square plus Ly square plus Lz square, right? We know it. Note down, guys, very important. From here we can get Lx square plus Ly square is going to be L square minus Lz square, right? Then expectation value of this is going to be this, or expectation value of Lx square plus Ly square is going to be, we can write like this, expectation value of L square minus expectation value of Lz square, right? We can write like this. So we can say this is the equation number 1. So if we get the expectation value of L square and expectation value of Lz square, and then if we subtract it, we'll get the value. Okay. Okay. Well, so now we'll solve. Now what we are going to do is we'll find expectation value of L square and Lz square respectively. Okay. So first we are going to get expectation value of L square. Okay. Expectation value of L square. It is going to be, we know, right? So this is going to be psi L square psi, right? So we'll solve it, and also we know, guys, you need to note down this is L square equal to this is the operator. Okay, L square equal to L into L plus 1 h cut square. This is the value, guys. Okay, where L is angular momentum number. Okay, angular momentum quantum number. Okay, so we'll put the value. So this is going to be L square, and here we are going to put the value. So values are going to be, value of psi is 1 upon 5. So bra is going to be, this is a cat psi. Okay, so this is this one, this is a bra, this is a cat actually, like this, sorry. Like this, right? So we can take bra as well, and so because there is no imaginary term, right? Here you can see, so the bra is going to be the same with bra sign, right? Bra eigenfunction sign. So okay, so we'll write it 1 upon 5. This is going to be the same. Okay, so 3 psi 1 1, sorry, 3 psi 2 1 1, 3 psi 2 1 1 plus psi 2 1 0 minus root 15 psi 2 1 minus 1 minus 1, then L square, and this value is again going to be 1 upon 5, the same value 3 psi 2 1 1 plus psi 2 1 0 minus root 15 psi 2 1 minus 1. Okay, this one. So now we know how to operate it. So 5, this term and this term, these are multiplication, will take together, so it is going to be 1 upon 25. Okay, and we'll operate it. So this is psi 211 plus psi 210 minus root 15 psi 21 minus 1. Okay, and we'll operate L square with this. Okay, so this is going to be 3 L square psi 211. I'm writing all these steps, guys, so that all your doubts will get clear. Okay, so 3 L square, and then L square psi 210 minus root 15 L square psi 21 minus 1. Okay, so here we know, like, we know how to operate the L square psi 211 is going to be L into L plus 1 h cut square, where value of L is 1. Similarly here, here also value is 1, here also value is 1. Okay, so this value is going to be 125 3 psi 211 plus psi 210 minus root 15 psi 21 minus 1, and this is going to be this one, this 3 L is 1. Okay, so 1 into 1 plus 1 h cut square, this value is going to be this. Okay, because we have operated this L square with this, so this is going to be this value. The value of L square is going to be this. Okay, L is 1 here, and then psi 211 plus this is going to be again 1 into 1 plus 1. Okay, h cut square psi 210 psi 210, then minus root 15, and this value is going to be 1, same because L value is value of L is 1 here as well. L 1 into 1 plus 1 h cut square psi 21 minus 1. Okay, so now we'll solve it. So this is going to be 1 into 1, 1 plus 1, 2, 2 1, 2 1 is 2, this is 2 h cut square, 2 h cut square, 2 h cut square, right? So this we can take common, so it is going to be 2 h cut square upon 25. Okay, and this is going to be, we'll operate it, so 3 3 is a 9, and this is going to be psi 211 psi 211, right? This value is going to give 1, so I'm going to write here directly. Okay, this is going to be 9, and then we'll operate this with this, right? 2 h cut we have already taken common, so it is going to be plus 1, Okay, then this one minus minus plus root 15 root 15. If you multiply root 15 with root 15, so this is 15, and side 2 1 side 2 1, that value is 1, right? So this is the one. So now this value is 25, 25, 25 will get cancelled, and the value is going to be h cut square. The expectation value of L square is 2h cut square. Okay, now we will find the expectation value of Lz square. Okay, L square, Lz square. Okay, that we are going to find, and here we know, so this is going to be psi Lz psi. Okay, yes, here we know if Lz, value of Lz square is going to be L into, sorry, it's not correct, my apology. So it is going to be m h cut, m is the magnetic quantum number, m h cut whole square. Okay, so this is the value, you need to note it, very important. Okay, then we will be able to solve it. Now the same thing, we'll put the value. So this is going to be Lz square, Lz square this value is going to be, we'll put the value. So this is 1 upon 5 3 psi 211 plus psi 210 minus root 15 psi 21 minus 1. Okay, and then Lz and this value is going to be same, that is 1 upon 5 into 3 psi 211 plus psi 210 minus root 15 psi 21 minus 1. Okay, so we'll again multiply it, so it is going to be 125, and Lz will multiply, so this is going to be 3 psi 211 plus psi 210 minus root 15 psi 21 minus 1. Lz we are going to operate it, so it is going to be Lz psi 211 plus Lz psi 210 minus root 15 Lz is also here psi 21 minus 1, right? This is the one. So now 1 upon 25 1 upon 25. So here you can see Lz, so value of Lz is m h cut square, the m value of m is 1 here, right? So 1 h cut square, so here it is going to give h cut square. Here this value is going to be 0 because value of m is 0. Here it is minus 1, so m h cut square, so value of Lz is going to be h cut square, right? So we'll write it, so it is 3 psi 211 plus psi 210 minus root 15 psi 21 minus 1. Okay, and this is going to be 3, this value is h cut square, right? 3 h cut square psi 211, this value is 0, or this value is going to be 15 h cut square psi 21 minus 1, right? Now we'll operate it, so it is going to be 1 upon 25 so 1 upon 25. Okay, so we'll solve it. So this is going to be 3 3s are 9, h cut square will take common. Okay, so h cut square is there, so we'll take h cut square outside. This is h cut square, so this is going to be 3 3s are 9, side 21 side into side 21, so that is that value is 1. Similarly, this value is 0, and here it is going to be minus minus plus 15, and the side to 1 is 1, and this is h cut square is already taken common, so this one. So this is going to be 15 9, right? This is 24 h cut square upon 25. Okay, so this is the value. Now we have got the value of Lz square and L square, right? Now we'll put this value in equation 1, this equation. Okay, so this is going to be Lz square, then this is in equation 1 Lx square plus, okay, this value is going to be Lx square plus Ly square, the expectation value of this, that is expectation value of L square, which we have got it, that is 2h cut square, and expectation value of Lz square we have got 25 h cut square upon 24 h cut square upon 25. Okay, so this is going to be we solve it, right? 50 h cut square minus 24 h cut square upon 25, and this value is going to be 26 h cut square upon 25. Okay, this is the answer, guys. We'll check which option is matching. Okay, so the option number D is the correct one, 26 h cut square upon 25, right? 26 h cut square upon 25. So it's a very good question, guys. So it is solved. Now I hope you understood it, guys. So now I'm going to solve next question. Okay, question number 2. These are very important questions, guys. Okay, so question number 2 is it is a question related to degenerate perturbation theory, right? So we'll solve it. So question, we'll write it first. So consider a two-dimensional infinite square well, two-dimensional infinite square well, and the potential is given V, which is function of x and y, that is equal to Vxy, that is 0 if x is between 0 to a, and y is between 0 to a. Okay, and else infinite otherwise. Infinite otherwise. Okay, and its normalized wave functions are normalized eigenfunctions are normalized eigenfunctions are psi, okay, psi nx ny, nx comma ny, which is function of x and y, is given 2 by a sine nx by x upon a sine ny pi y upon a, ny pi y upon a. Okay, where nx comma ny equal to 1, 2, 3, so on. Okay, so this is the normalized eigen function is given, and the two-dimensional potential well is given. So if a perturbation h dash equal to v naught, which is if x is between 0 to a by 2 and y is between 0 to a by 2. Okay, then perturbation is v naught. Okay, and 0 otherwise. Okay, is applied, then this is the perturbation which is applied. Okay, then the correction to the energy of first excited state, to order v naught is. Okay, so then correction to the energy of first excited state. Okay, correction to the energy of first excited state to the order v naught is. Options are given. Option number A, which is v naught upon 4. Option B is v naught by 4 into 1 plus minus 64 upon 9 pi square, option C is v naught by 4 1 plus minus 16 upon 9 pi square, and option D is v naught by 4 into 1 plus minus 32 upon 9 pi square. Okay, this is the question which is given. Okay, the question is, consider a two-dimensional infinite square well. Okay, two-dimensional infinite square well, and the potential is given, that is vxy is 0 if x and y are between a to 0, else infinite. Okay, otherwise it is infinity. Its normalized wave function is given Okay, this is the normalized wave function. Now, and if perturbation in this system, okay, perturbation as dash equal to V naught, if x is between x and y are between 0 to a by 2, okay, 0 otherwise is applied, then the correction, we need to find correction to the energy of the first excited state in order V naught. Okay, that's we need to find out. Very simple, and we are going to use degenerate perturbation theory. Okay, so normalized wave function is given, guys. Okay, normalized wave function I'm going to write. So psi is given, this one. Okay, psi nx comma ny, okay, which is function of xy is given. Okay, this is given. This is 2 by a sine nx phi x upon a sine ny phi y upon a. Okay, this is given. So for first excited state, so for first excited state, what is the degeneracy? So so we know the energy of energy of the function. Okay, energy we know if it is in two-dimensional potential. Okay, the energy we know, that is nx square plus ny square, nx square plus ny square into pi square h cut square upon 2ma square, right? So if we put nx and y equal to 1 2 respectively, and and nx and y equal to 2 1, so this is going to give same value, that is 5 h cut square upon 2ma square, right? So the degeneracy is 2 for first excited state, right? So we'll find out the wave function for it. So wave function is going to be there would be two wave functions, okay, for this state and for this state. Okay, so let's suppose phi 1 is going to be for n equal to 1 and 2, so this is going to be 2 upon a, okay, 2 upon a sine nx equal to 1, so it is going to be sine pi x upon a into sine 2 pi y upon a, and phi 2 is going to be 2 upon a sine nx equal to 2, right? So 2 pi x upon a and sine ny equal to 1, so sine pi y upon a. So this is going to be the wave function for first excited state. Okay, so this is the one. Okay, so now we need to find the correction to the energy of first excited state, right? So because it's a degenerate, we have to use a degenerate perturbation theory. So there is a formula. So first of all, we need to find out the matrix H11, H12, and H1, H21 and H22. This matrix we need to find. Okay, and after that, suppose the correction to the energy is E dash. So what we are going to do is, we are going to do, suppose this is the we can say A. Okay, this is the matrix. Right? Then what we are going to do, we'll do A minus IE dash. Okay, is going to be 0, and by that we'll find the value of E dash. This is the correction to the energy of first excited state. Okay, so here H11 is going to be and then this value will be like this. This value is going to be, H11 value is phi 1 H dash phi 2. Okay, minus E dash. Okay, we're solving this, and this is going to be phi 2 H dash phi 1, and then this is going to be phi 1 phi 2. Okay, this is going to be phi 2 H dash phi 1, and this is going to be phi 2 H dash phi 2. Okay, I think I did mistake here, so I'm going to correct it. This is going to be 1 2, and this is going to be 1 1. Okay, this is going to be 0. We'll put this value here, and here is minus E dash, minus E dash. This value is going to be 0, and we'll solve this matrix, and we'll find the value of E dash. Okay, so the value of H11 is this. Okay, value of H11 is phi 1 H dash phi 1. Okay, similarly value of H12 is phi 1 H dash phi 2. 121 is H2, value of H21 is going to be phi 2 H dash phi 1, and value of H22 is going to be phi 2 H dash phi 2 minus E dash. Okay, this is we have used matrix property, right? I can find the eigenvalues of the matrix, right? Similarly, we are going to get the correction to the energy of first excited state. Okay, so we have to solve this matrix, and then we'll find the value. But before that, we need to find H11, H22, right? That is this one, this one, this one, this one. Okay, so we'll find it one by one. Okay, I'm solving every steps of the question. Okay, so that you will not get any doubt. Your all doubts will get clear. Okay, so now we'll find H11. Okay, H11. So this is going to be phi 1 H dash phi 2. Okay, we'll find it. So we know the value of phi 1, right? So this is going to, so we'll write integration term. This is going to be integration 0 to a by 2, right? Because here in question it is given as dash, right? So the limit is going to be a by 2, and then phi 1. Phi 1 value is going to be, the value of phi 1 is a by 2 sine pi x upon a sine 2 pi y upon a. Right here I can show you. I'm going to show you this one, phi 1, okay, and this is the value of phi 2, and this is the cat phi 1. So if we take bra phi 1, this value is going to be same because there is no imaginary term iota term, okay, else sign gets changed. Okay, this one, and then h dash is going to be, here we can write like this as well, 0 to a by 2 phi 1 star h phi 2 dx, okay. Yeah, h is given, h dash is given, right? Okay, so now we'll write value of h dash. H dash is given, that is v naught, okay, for a bit, if x and y is between 0 to a by 2, else it is 0. This is double integration 0 to a by 2, okay, 0 to a by 2. This you understood, guys, okay. This is one, okay, v naught, and then we'll write the value of phi 2. This we know, a by 2 sine of 2 pi x upon a sine 2 pi y upon a dx dy, okay. So this is the one, so it is going to be, so now you need to integrate it, right? Okay guys, so very simple integration which we have already studied in 11th 12th, okay. Okay, so now what we can do is sine 2 pi y and sine 2 pi y and this sine this one sine pi y. Okay, so here we need to find, this is phi 1, guys, because we are finding h11 phi 1. So this is going to be the same sine pi x upon a, same one, and sine pi y upon a, okay. So this is going to be, here we can take common, that is v naught, take outside, okay, v naught upon v naught a square by 4, okay, v naught a square by 4, we can take common. Have you done any mistakes? Let me check. Okay, the mistake is here. This is 2 upon a, right? The phi 1 phi 2. So here we have written a by 2. It's 2 upon a. 2 upon a. Similarly here, it's 2 upon a. Okay. And so this is going to be 4 v naught upon 4 p naught upon a square will be common. So this is going to be integration 0 to a by 2 sine square pi x upon a dx into integration a by 2 sine square pi y by a dy, okay. So this is the integration we need to solve. So we can easily solve it. This one, right? We know the value of sine square. So we'll find this, like, because we know the formula, right? Cos 2x equal to 1 minus 2 sine square x, right? From there we'll put the value, we'll get the value, right? Sine square x. So this is going to be uh, 1 minus 2 cos x, 2 1 minus 2 pi x, 2 sine 2 cos pi x upon a by 2. Yeah, similarly this one, because we know the formula, I'm going to write here. Cos 2x equal to 1 minus 2 sine square x. From here we can easily find the value of sine square x, right? So this is going to be 1 minus cos 2x upon a. We'll use this formula here and we'll find out the value. So it's easy integration, so you can do it. Okay, so this is going to be now we'll solve it, and after solving, what we are getting here, if we solve it, so we are getting the value, that is v0 by 4. You can try it. If you have any issue, you can ask me. Okay, very simple integration which we have already studied in 11th and 12th. Okay, so this is going to be v1 v by 4. Okay, now we are going to find h12. h12, this is going to be phi 1 h dash phi 2, right? Here also will put the value. So this is phi 1. What is phi 1? We know. So this is again integration 0 to a by 2, 0 to a by 2. Okay, we know the value of phi 1, right? Phi 1 is 2 by a sine pi x upon a sine 2 pi y upon a dx plus, sorry, my apology. So this is write it together. Value of h dash is v0. Okay, and then this 2 by a, or phi 2 value is 2 by a sine pi x upon a, just let me check the pair here, this one, right? Phi 2 is 2 by a sine 2 pi x upon a and pi y upon a. Okay, so sine 2 pi x upon a sine pi x upon pi y upon a. Pi y upon a dx dy, right? This will be the value, because we know here this is double integration 0 to a by 2, 0 to a by 2, phi 1 star h dash phi 2 and dx dy. Okay, it's in 2D, you know. We have now so now we have put the value. Now we'll simplify it. Okay, so this is going to be 1 2. So the calculation is lengthy here. Okay, this is going to be h12. It's going to be 0 to a by 2. Here with we are going 4 v0 upon a square will be common. Okay, It is going to be 0 to a by 2. This is sine pi x upon a into sine 2 pi x upon a dx integration. So we'll take terms functions of x one side and function of y in another side. So this is going to be sine 2 pi y upon a 0 to a by 2 and sine, this is pi x upon 2 pi, this is sine 2 pi and sine pi y upon a dy. Okay. Okay, so now we can solve it. So we know so we'll multiply by 2. So we know here sine 2 sine a sine b, this formula we know, right? You can multiply by 2 and divide by 2, these two, to make it like this, 2 sine a sine b. Okay, and this formula we know, cos a minus b plus cos a plus b, right? We'll use this formula to solve this. Okay, so this is going to be, I'm just telling you the procedure, you can integrate it. Okay, okay, so this is going to be 4v naught upon a square, and this is integration 0 to a by 2. So I'll multiply by 2 and divide by 2. Similarly, multiply by 2, divide by 2, because to make it 2 sine a sine b. Okay, so this is going to be cos a minus b. Okay, pi x minus 2 pi y upon a plus cos a plus b, cos. So I'm not writing like this, I'll write like this. So this is going to be like 1 upon 2 is here. So to sine a minus b. Okay, so this is going to be minus pi x minus 2 pi x. This is going to be pi x minus pi x, cos minus theta, cos theta, right? So this is sine pi x plus here sine a plus b, sorry, cos a plus b. So this is going to be cos 3 pi x upon a. Okay, this is the one into this is dx. Okay, similarly 0 to a by 2, here it is going to be 1 upon 2 this is the limit, 1 upon 2 sine a plus b. Okay, sorry, cos so sine a sine b, so you will cos a minus b, so that is cos pi x plus cos a plus b. So this is going to be cos, this is pi y, guys, pi y, so cos 3 pi y dy. Okay, this is, now it's a very simple, you can easily integrate it. You know the integration of cos pi x, cos 3 pi x, 3 pi x, similarly this. Okay, so you can do it, a simple integration. So I'm going to answer for it. So after solving this, the answer we are going to get is v naught into 16 upon 9 pi square, that is v naught, that is 16 v naught, 16 v naught upon 9 pi square, 16 v naught upon 9 pi square. Okay, so this is the value of h12. So there is a one thing there, guys, in Csirnet perturbation theory in 2D case, right? So if you can calculate it as well, you will get the same value. H11 is equal to H22. Okay, H22 and H22 equal to H, my apology. So it is H12 equal to H21. So we don't need to find the value of H22 and H21 again. So now from here we can easily find H22 is equal to H11, right? And H1 value we know, V0 upon 4. Similarly, H21 is going to be H12, and that value we know, that is 16 pi square upon 9. 16 pi square upon 9, right? Which we have find 9 pi square, sorry, 9 pi square. Okay. V0 upon 9 pi square, right? So we'll put this value here, the equation. So this equation, let's say this equation is number 1. So we'll put this value here. Let the energy, because energy eigenfunction, right? E dash is the correction to the energy of first axis, right? So E dash, we know how to solve this matrix, right? This is the energy eigenvalue. There's correction in the energy of first static state. Okay. So in equation we are going to put the value. So it is going to be H. This value is V0, right? This is the H11, right? So it is going to be V0 by 4. V0 by 4 minus E dash, and this value is going to be 16 V0 upon 9 pi square, and this is going to be 16 V0 S22, right? V0 upon 9 pi square, and this is going to be V0 by 4 minus E dash. Okay. So this you need to know, guys. Okay. You can solve it. If you calculate it, you get the same value. Okay. Important, guys, because this question is already lengthy, so you need to know this thing, right? Else you will just waste your time, because you are going to get the same value. And this is equal to, we have put this in equation 1. Okay, this is going to be 0. Now we know how to simplify it. So this is going to be V0 upon 4 minus E dash whole square minus 16 V0 upon 9 pi square whole square is going to be 0. And so this implies V0 by 4 minus E dash is going to be, we'll take this side, right? So this is going to be plus minus 16 V0 upon pi square. Okay. And so now we'll find out this. So implies E dash is going to be V0 upon 4 plus minus 16 V0 upon 9 pi square. Okay. So this value is going to be okay. So now we can take V0 by 4 as common. Okay, V0 by 4 as common. So this is going to be 1 plus minus, and this is going to be 64 upon 9 pi square. So this is the answer, guys. Very important question and lengthy as well. Okay, so we have used degenerate perturbation theory. So if it's a degenerate case, if there is a degeneracy in the perturbation, then we make a matrix, we solve that matrix, and by that we get the correction in the energy. Okay, so this is the answer. So which option is matching? Let's see. So option C, option B is matching. Option B is the correct. Okay, option B. Option B. Okay, so option B is the correct option for this. Okay, very important question. and lengthy as well. So you need more practice. You need to for these questions you need more practice, guys, because there is a lengthy integration which you need to solve it. Okay. Well, this is the one. Now we'll solve next question. Next question is a very good question. Okay. Next question is, this is, how many questions we have done so far? 2 questions. Okay. Question number 3rd. Question number 3rd is, the bound on the ground state energy of the Hamiltonian with an attractive delta function potential, namely h equal to minus h cut square upon 2m d square upon dx square minus alpha delta x. Okay, this is derived delta x. Okay, using the variational principle, using the variational principle with the trial wave function psi equal to a e to the power minus bx square is, and there is note is also given, note integration 0 to infinity e to the power minus t t to the power a dt is equal to gamma a plus 1. This is given. Okay. And options are given. Option number A which is minus ma square upon 4 pi h cut square. Option B is minus ma square upon 2 pi h cut square, Option C is minus ma square upon pi h cut square, and option D is very good question, guys. Ma square we have to use, we are going to use variational principle here. Okay, so I'll explain in detail. Okay, so this is minus ma square upon root 5 root 5 pi h cut square, root 5 pi h cut square. Okay, so question is the bound state on the ground state, the bound on the ground state energy, okay, of the Hamiltonian with attractive delta potential, that is namely h equal to minus h cut square upon 12 d square upon dx square minus alpha delta x using variational principle with the trial wave function which is given, right? So using variational principle you need to find out the energy, ground state energy, okay, minimum ground state energy, okay. So that's what this question is saying, okay. So minimum ground state energy, ground state energy which is minimum, which you need to find out, okay. So I'm going to solve it. So we have given h equal to minus h cut square upon 2m d upon dx d square upon dx square minus alpha graph delta x, right? This is given. So we need to find using variational principle, we need to find energy, okay, ground state energy which is minimum, that is we need to find E minimum, okay. This we need to find. So trial wave function is given, so we are using variational principle, guys. So how we are using variational principle you need to know, okay. So this I'm going to explain. So psi is given, psi which is trial function, okay, function of x which is given a e to the power minus bx square, this is given, okay. Okay, so first we are going to find Hamiltonian, that is expectation value of Hamiltonian will find, okay, that is psi h psi will find, okay. After that what we are going to do is, after finding this, so so we need to find this weight. So the trial wave function is given and b is the parameter here, okay, b is the parameter. So what we'll do after getting this uh, expectation value of Hamiltonian, right? What we'll do, that is the ground state energy of we'll find ground state energy, okay, of the system. And after that what we'll do, what we are going to do is, for variation parameter, there's a variation parameter, right, b. So for variation parameter what we'll do dE upon dB, okay. Will differentiate the ground state energy with respect to variation of parameter, that is with respect to v, okay, and we'll make that equal to 0, and from there we'll find the value of b, and then we'll put this value b in the expectation value, that is the ground state energy, okay, and we'll get the required solution, okay, that is the E minimum, okay. So now I will solve it, then it is going to be clearer to you, okay. Okay. So here I'll tell you the way you can make a question simpler and shorter, okay. Okay. So wave function is given. We have written wave function, okay. Total energy will find out first. So okay. So first we will normalize the wave function, okay. Normalize the wave function. So we know how to normalize it, right? So this is minus infinity to plus infinity. This is psi star psi dx is going to be 1. Okay, so we'll put here value. So this is going to be psi star, there is no imaginary term, right? So psi star is also same. So this is a e to the power minus bx square, and then a e to the power minus bx square dx minus infinity plus infinity, that is going to be equal to 1. I hope you know how to normalize the wave function. Okay, so this is the one. This is the normalization condition. Okay, so this is going to be integration. This mod a square is going to be outside. This is integration minus infinity to plus infinity. This is going to be e to the power minus 2 bx e to the power minus 2 bx square dx equal to 1, right? How? Because these two are same, right? And we know bases are same, then powers get added, right? So bx square plus bx square is going to be 2bx square, and now we need to find it. So this integration, guys, this is very important. So I'll tell you the one this integration you need to memorize it, very important, and you will use it in many places, guys. Okay, very important integration. This is I'm writing it with red pen actually. It's very important. So integration minus infinity note down and memorize it. Okay, guys, very important. You can solve very complicated integration easily if you know this formula. Okay, this is minus infinity to plus infinity e to the power minus ax square. This is always equal to pi upon a. Okay, very important, note down. Okay, so here a is this constant, right? What is a here? It is 2b. Okay, so we'll write like mod a square is going to be, this is going to be pi upon a, right? A is 2b here. Okay, equal to 1. That implies mod a square is going to be, value of mod a square is going to be root 2b upon pi. Okay, so here we have found the value of this, or that implies value of a is going to be 2b upon pi to the power 1 by 4. Okay, now it is a normalized wave function. So normalized wave function is going to be psi equal to psi equal to this is going to be, let me just check whether the internet is working fine. Okay, so psi is going to be value of a is 2b upon pi to the power 1 by 4 e to the power minus bx square. Okay, now this is the normalized wave function, guys. Okay, normal, we have normalized it. Okay, normalized wave function. Okay, okay. So next next we need to find value of expectation value of ground state. Okay, so this is, we need to find this e, or this is going to be we can write like this, expectation value of kinetic energy plus expectation value of potential energy. Okay, so first we will find expectation value of kinetic energy. So this is going to be, we know here the total Hamiltonian is given, right? This one, del h square upon 2m del x square minus this minus del delta x, right? So this is going to be integration psi star minus del square upon del dx square psi dx, right? So this is going to be and this is minus infinity to plus infinity. We know it, right? So this is going to be integration minus infinity to plus infinity, and value of psi star is the same because there is no negative term, so it is going to be a psi, this is e to the power this is going to be like this, right? A e to the power minus bx square into minus del upon del x square h cut square upon 2 is also there, okay, minus h cut square upon 2m, okay, this one and this minus this one, right? So this is going to be minus h cut square upon 2m d upon dx d square upon dx square e to the power minus bx square, okay, this is dx. A is also there, okay, a, so a is going to be mod a square, okay. So this is going to be mod a square value we know, this is I have already find, right? This is root 2b upon 5, root 2b upon 5 minus integration to plus infinity, minus infinity to plus infinity. So this is going to be e to the power minus bx square. So there is a lengthy calculation, guys, okay, integration. Okay, so this is going to be integrated, guys, okay. So integrate, I will differentiate it, sorry. This is going to be e to the power minus bx square, so we know the differentiation, right? So we'll take is at a t, and this is going to be minus 2bx, okay, this, and dx is here. So this is going to be, again we'll find t, it is going to be 2b upon 5 integration minus infinity to plus infinity again we'll integrate it, sorry, differentiate it. So it's e to the power minus bx square, this again we are going to differentiate. So there are two functions now, 2b minus 2b, okay, so there are two functions now. So it is going to be, first this is the one, right? So it is going to be minus 2b minus 2b minus 2bx minus 2bx, first function, differentiation of second. So differentiation of second is going to be this one, e to the power minus bx square, again minus 2bx, plus here going to be minus 2b e to the power minus bx square will remain here, and integration of x is going to be this one, right? This is the x and this is going to be 1. right? This is the one, and dx. So this is going to be 2b upon pi integration minus infinity to plus infinity e to the power minus bx square. Will go here, so it's I'll solve it here. It is going to be minus minus plus 2 to the 4, so 4b square e to the power minus 2bx 2bx dx. Again, this is going to be plus minus infinity to plus infinity. Here this is minus 2b will remain as it is, and e to the power this will multiply with this, right? So this is going to be e to the power minus e to the power minus 2bx square dx. We'll solve it, okay? So this is going to be this is 4b square, okay, and this is b square, and this is 4b. So b will take a common, so this is going to be root 2b upon pi into b. We are going to take common, so b is here as well, okay. So this is going to be, so this this one is also the same. B is taken common, so it is going to be b again. Here x is also there, it's x square, guys, okay, x square is also there. So this is going to be 2 to the 4b square, and then b and x square, okay. This integration we should know it, guys, okay. So I'm going to write this as well for you. This is also you need to remember, okay, and you need to memorize. I'm writing here like integration minus infinity to plus infinity x square to the power minus ax square, okay. This one, x square and ax square. So this is going to be root pi upon 2 e to the power 3 by 2, okay. Very important. I'll write in next page. Here I'm going to solve. So this is integration minus infinity to plus infinity x square, because these formulas you must know, guys. It is going to make your calculation easy. You can this question is already a lengthy question, okay. This is e to the power minus infinity to plus infinity x square e to the power minus ax square is going to be root pi upon a 2 a to the power 3 by 2, okay. Here I'm going to erase it because I'll solve it further. So this is going to be b is here 4b, okay, and we'll write here the value. So this is going to be same root pi upon 2 b is here, right, 2b, so it is going to be 2b 2b to the power 3 by 2, okay, and plus this value, this is minus, sorry, this is going to be minus and 2b, b is already common, so 2, and this integration we know, right, e to the power minus of pi upon root, sorry, this is root pi upon 2b, right, a is b here. I've already told this before, that formula, this one, okay. Here also I'm going to write this formula because this will be easy. Minus infinity to plus infinity x square e to the power minus x square, okay, dx, ax square, okay, a is the constant. This is going to be, I'm telling each and every step, guys, so that your all doubts will get clear, okay. Please practice and revise these questions, okay. So this is going to be x square e to the power minus ax square. So okay, this integration is going to be root pi upon 2 e to the power 3 by 2, okay. This formula I have used here, okay, e to the power x square minus 2b x square. 2b is a here, a constant, okay. This is the one. Okay, minus h cut square upon 2m will be also here. H cut square upon 2m minus h cut square upon 2m minus h cut square upon 2m, okay. Here also minus h cut square upon 2m minus h cut square upon 2m. So this is going to be like this, okay. Well, so this one is going to be, value of p is going to be now b, okay. How? Minus because this one is going to get cancelled, okay. So this is 2, right? So this is going to be 2, this 2b, and this is going to be 4. 4 will get cancelled, b will get cancelled with b, and this is going to be this one. A is also here, guys. A square is also here, okay. If we skipped it, this is a square is also here. I'm writing here like mod a square, okay, into mod a square, 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 right? So mod, so I'll solve it now. This is minus, it is going to be, I'm going to solve this as well, okay. So this is like x cut upon 2n, like this, okay. This value, this one, okay. So here we'll find the value a square and h cut square. Just wait, guys, let me check. Right. So this is going to be, so we'll write the value, correct, minus h cut square upon 2m. Actually, guys, we have already, this is a, I have put the value, so you no need to write this one, because value of this I have already. This one not required because I have put the value of a square here, okay. This one is correct. So this pi ab pi bb, if we take common, this will get cancelled, okay. And this is going to be 4, okay. I'll write it minus h cut square upon 2m 2b upon pi root, here we have also taken common pi upon 2b, okay. This we have taken common, this will get cancelled actually, and b is also here, and this is going to be 4b into root pi, we can write it like this, 4, this 2 will be common like this, 4 into b, and this is going to be 2b root 2b, okay. And pi upon root 2b we have taken, pi upon root 2b we have taken common already. So this is going to be like this, minus 2, right? This is get cancelled, this is 1, so this is going to be, value is going to be, value of t is going to be minus h cut, minus minus is going to be plus, okay, I'll write it, minus h cut square upon 2m. This will get cancelled, okay, this going to get cancelled into b minus, so this is going to be, b get cancelled, this is 1 minus 1, okay, 1 minus 2 is going to be minus 1, so this value is going to be h cut square b upon 2m, guys. Okay, now we are going to find value of expectation value of b. This is lengthy question, guys, so you need practice, you need to revise it and solve it 2-3 times. Okay, so this is going to be like, again, psi star psi, psi star v psi dx. Okay, it's normalized wave function, so this is going to be here we'll put the value, so this value is going to be like this one, right? This is going to be root pi upon 2b value of a square, and this is going to be, we'll put the value, so it is, and e to the power minus bx square, this value is, what is the value of b given, that is alpha minus alpha delta x, this is the value of b, okay, and that in e to the power minus bx square. Okay, e to the power minus bx square, and this is dx, and this is normalized wave function. The value of a square is, this is a is pi upon 2b to the power 1 by 4, so there are 2a, a mod a square is going to be pi upon 2, pi upon 2, okay, which I have already explained here, this one, 2b upon pi, okay, it's 2b upon pi, guys, 2b upon pi. upon pi, okay, so we'll solve it. So this is going to be root 2b upon pi, and this is going to be alpha, will take as common minus alpha, okay, into minus alpha we have taken common, it is going to be minus infinity to plus infinity, e to the power minus 2bx square, bases are same, so powers get added, okay, so this is dx, okay, del x, this is delta x dx, okay, this one we'll solve it further. So this is delta x, so this we can write it like this, root 2b upon pi integration minus alpha is also there, minus alpha integration minus infinity to plus infinity delta x e to the power minus bx square dx, this is 2bx square, right, 2bx square, So this is, we know, this delta x we can write like this because we know the Dirac delta property, right? So I have already taught Dirac delta function in detail in mathematical physics. So check my lecture. Okay, this we know. This is going to be minus alpha root 2b upon pi, and this value is going to be 1. How? Because we know integration minus to plus infinity delta x minus a x minus 0 fx equal to fa, right? So e to the power minus 0 is 1 because 0 comes between minus infinity to plus infinity, right? So this is the value of expectation value of that. This is the value of potential energy, okay, V. This is minus alpha root 2b upon pi. Okay, so now the total energy is going to be kinetic energy plus potential energy, which I have already mentioned earlier. I'll show you here. This one, right here. So we'll put the value. So total energy is going to be E is going to be P value is h cut square upon 2mb minus alpha root 2b upon pi, right? This one 2 minus L and this one is this h cut square b upon k, right? This is the E. This is the Hamiltonian. For we are using variational principle, right? The parameter is B. So what we are going to do for variation parameter, for variation as a parameter, it is going to be so for variation for finding variational parameter, okay, del B upon del E, that is energy value upon B with respect to B is going to be 0. So this will differentiate it with respect to B. So this is going to be del upon del B h cut square upon 2m, okay, B minus alpha 2b upon pi, okay, 2b upon pi. So this is going to be, these are lengthy questions, right? This is going to be 0. So we'll solve it further. And now we'll differentiate it. So it is going to be h cut square upon 2m minus alpha root 2 upon pi, and this is 1 upon 2 b to the power minus half. This is what's going to be, okay, this is equal to 0, and then from there we can find b, that is going to be 2ma square upon pi h cut square, pi h cut square. Okay, now so we have to find E minimum, right? Energy minimum. This is going to be, that is energy minimum, okay, and this is going to be, we'll put the value of B in equation 1. Suppose this equation is 1, guys, okay, this equation is 1. We'll put value here. Value of B is, we have already found this one. So if you put the value, so we are going to get minus ma square upon pi h cut square, okay. So this is the one, guys, minus ma square upon pi h cut square. So this is the answer. So It's the calculation is lengthy, guys, but very easy. You can easily solve it. So it's going to be, so which option is matching? Let me check. Option C is matching. Option C, this one, minus ma square upon pi h square. And this, okay, this is the answer, guys. And these two formula, very important formula, which you need to note down and memorize, guys. It will make your integration very easy. Okay, very important. This is very important, this one. In many questions in mathematical physics and quantum mechanics, you are going to get it. This is also important, guys. Okay, well, so this is the question, and okay, so this is like, so 1 hour and 40 minutes already there. One more question is remaining, so I'm going to solve that as well. Let me check. Is there any issue with network? No. Okay. Then, okay, guys, the class is already lengthy, so let me just check this question. Yeah, it's an easy one, so I think we should solve it. So I'm going to solve it. Question number 4. Okay. Question number 4 is, if the operators A and B, if the operators A and B satisfy the commutation relation, the commutation relation AB equal to I, where I is the identity operator. I is the identity operator. I is the identity operator. Then options are e to the power A, comma B equal to e to the power A, commutation of e to the power A. Okay. Commutation of e to the power A into A comma B. This is e to the power A. Option B is e to the power A, commutation of e to the power A with B is going to be commutation of e to the power B with A. Okay. And option C is commutation of e to the power A into B, e to the power A into B is going to be e to the power minus B, commutation of e to the power minus B into A. And option D is commutation of e to the power A, comma B is going to be with B, commutation of e to the power B with I. Okay. So this is the question. We need to solve it. So guys, we have been given the commutation, the property AB equal to I, okay, identity operator, and we need to find out, then we need to find out which expression is correct, okay. So identity operator, okay. So we'll check one by one, okay. So now option A we are going to check. Okay, so e to the power a, commutation of e to the power a, and we'll check it whether it is correct or not. Okay, so we know here, right, there is a property we know, this is the function of a, right? So del e to the power a upon a into ab, this is what we know, right? Commutation property, this is function of commutation of function of a with b, right? This is going to be, we know the property, this is del function of a upon a, del function of a with respect to differentiate this with respect to a into ab, that's we know, this is property, this property. So this is, so here we'll solve it. So this is going to be e to the power e with respect to a is going to be e to the power a into ab, and we know ab, a commutation of ab is given I, so e to the power a into I, so this is going to be e to the power a. Okay, so this is the answer. So option A is the correct, the option A is giving the correct value, right? This one, option A is the correct one, guys. E to the power a into b, this relation is correct, right? Because we know here this property, we have used this property, so we have differentiated e to the power a with respect to a, that is going to be a, and ab, value of ab is I already given, so this, so this value e to the power a, this is the answer. Okay, so this is the correct answer, guys. So option A is the correct one. Very simple question. Well, guys, so guys, time is already it is almost 2 hours. Okay, guys. So guys, I'm going to stop here, and thank you so much for watching my lecture. And I also would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are going to help you to crack the exams related to physical science. Thank you, guys. Bye now.